Okay, we're doing number 89 in section 8.5, and we're asked to simplify this expression. And that means we're asked to rationalize the denominator. Now, unlike the problems we've been working with so far, our denominator here has an expression itself, the square root of 6 minus the square root of 5. So we're going to need to use the conjugate to rationalize this denominator. The conjugate means you take the same expression, but you change the middle sign. So that means this is going to be square root of 6 plus the square root of 5. Remember, I have to do the same thing to top and bottom. So what I'm going to do is I'm going to FOIL out both top and bottom. Now, as you do more of these with the conjugate, you will see the bottom always falls into a similar pattern. But I find it's very helpful, even though you know what the pattern generally is, that those middle terms are going to cancel out, that it helps to actually do the complete FOIL process, because it is very easy to get your signs confused, especially as we start in 8.7, work with imaginary numbers, the I. It's very easy to get those signs confused, and I find that by writing it out, I don't make sign mistakes. This is especially important on a test where you don't want to lose those easy couple of points that sign mistake is going to cost you. So, even after years of experience, I still FOIL, so I recommend you do the same. So, starting with the top, I'm going to FOIL out first, so square root of 2, square root of 6. First, outer, so the two far ones, square root of 2, square root of 5, inner, 6, and last, 3, square root of 5. Okay, that's the numerator. Now I'm going to take the denominator and do the same thing. First, outer, inner, and notice I'm taking the signs with me, and last. Don't forget the signs. The signs are very important because in the middle and the bottom, that's what's going to help you cancel out. It's also important because that is very easy, again, to make that mistake, lose that sign, and again, lose a couple of points you shouldn't have lost. Now I'm going to simplify. So remember our radical rules. Remember, we can take apart multiples. So if we have the square root of 12, we can divide it into 4 and 3. The square root of 12 becomes the square root of 4, the square root of 3, so then we can take the square root of 4. Remember that procedure? We're going to do the same thing, only in reverse. We've got the square root of 2 and the square root of 6. We're going to turn it back into the square root of 12. Here, square root of 10, square root of 18, square root of 15. Now on the bottom, have the square root of 36 plus the square root of 30 minus the square root of 30 minus the square root of 25. Okay, now this point I'm going to start looking, what can I simplify? So I just mentioned 12, right? So this is 4 and 3, so this becomes 2 square root of 3, square root of 10. This is 9 and 2, square root of 15. Now on the bottom, what's the square root of 36? 6, right? These two cancel out. Now, what's very important is just like terms. Remember, we can add 5x plus 5x and get 10x, but we cannot add 5x plus 5y because they're unlike terms. Radicals work the same way. If we have 5 times the square root of 2 plus 5 times the square root of 2, we can combine them and get 10 times the square root of 2. If we have 5 times the square root of 2 plus 5 times the square root of 3, we cannot combine them. They're unlike terms. Consider the radicals just like variables, and if the number under the radical is the same, then you can't combine them. So don't fall into that trap of thinking you can, just like the multiplication rule, we can split them up, put them back together. You can't do the same with addition and subtraction, just like it doesn't work when we're working with like terms and variables. But here we have the square root of 30 and the square root of 30. These are the same, they're like terms, so we can cancel them out. This last one, the square root of 25, is 5. Now, looking at this numerator, do we have any like terms? We have the square root of 3, the square root of 10, the square root of 2, the square root of 15. Do any of these match? No. So therefore, this numerator cannot be simplified anymore. The bottom, though, this is 1. Anything over 1 is itself, so our final answer is just 2 times the square root of 3 plus the square root of 10 minus the square root of 2 minus the square root of 15. Now the bottom won't always cancel out. Sometimes you'll have another number down there, say 3, 17, doesn't matter. But it is important to work it out, see what you can do, see how far you can simplify it. Sometimes you might be able to combine terms in the numerator. In this case, you can't. So this is our final simplified answer.